Hey everyone, and welcome. Today, we're going to go way beyond just writing simple queries. We're going to unlock the real power hiding inside your database. Seriously, we are about to turn MySQL from a basic filing cabinet into an intelligent, automated powerhouse. Let's dive in.
Think about that for a second. We all know a database is fantastic at storing data and answering our questions about it. But what if it could do more than just answer? What if it could actually analyze a situation, react to it, and kick off a bunch of complex tasks all by itself? Well, that's exactly what we're going to build today.
You see, on one hand, you've got your standard static query. It's like asking someone to grab one ingredient from the pantry. Simple. But on the other hand, you have what we're talking about, a dynamic program. This is what we call a stored procedure. Think of it like a complete recipe, a set of instructions you can use over and over again to automate some serious workflows right inside the database itself.
All right, so let's start that journey. We're going to build our first little program together, step by step. And we'll start with the most fundamental piece of the puzzle, how it gets and handles data.
Every program needs raw materials to work with, right? And for a MySQL procedure, that means getting data in, sending results back out, and of course, having a place to store information while it's in the middle of working its magic. So let's see how that gets done.
So, parameters are basically the doors and windows for your program. In lets you pass a value into it, like an employee ID you want to look up. Out is how the program hands a result back to you, like the employee's name. And then there's INOUT. This one is clever. It's kind of like a secret weapon. You send a value in, the procedure does something to it, and it sends the updated value back. Super efficient.
Okay, so you've passed an employee ID into your program. Great, but how do you actually get their specific salary from a giant table so you can use it in your logic? You don't want the whole table, you just want that one number. Well, for that, there's a really simple and powerful command.
And boom, this is it. Select into is the most direct way to snatch a single value from a query and drop it right into a variable. We're literally telling MySQL, hey, go find the salary for employee number 1, and then stick that value into my variable called imp salary. It's so simple and so effective.
Now, while we're talking about variables, here's the deal, and this is super important. For the logic inside your procedure, you pretty much always want to use local variables. These are temporary variables you declare that only exist while the procedure is running. It keeps everything clean and predictable. The other kinds, user-defined with the @ sign, stick around for your whole session. And system variables with the double @ sign, well, those are for server settings, so let's not mess with those. Stick to local.
Okay, we've got our data flowing. Now for the fun part. It's time to give our program a brain. This is where we stop just fetching data and start actually evaluating it and making some intelligent choices.
And the absolute foundation of any decision is, of course, operators. You already know these. We use them to do math, compare things. Is the salary between 50,000 and 70,000? Or we combine conditions with and or to build some really complex rules. These are our basic tools for logic.
And here's where we put those tools to work. The classic if-then-else structure is just perfect for creating a decision path. It checks a condition. If it's true, it does one thing. If not, it can check another condition with else if, or it can just fall back to a default action with else. It's absolutely perfect for tiered logic, like figuring out a performance bonus. An if statement is great for 2 or 3 paths for sure, but what if you have 10 or 20? Stacking a bunch of if statements inside each other can turn into a total mess, and it gets really hard to read. We definitely need a cleaner way to handle that. And that cleaner way is the case statement. This thing is so much more elegant. It just works like a switch. It looks at the rating variable and says, okay, when it's A, give me high. When it's B, give me medium. For everything else, just default to low. It's just a much more readable way to handle a bunch of different conditions.
All right, our program can get data, it can make decisions. Now, let's give it an engine. Loops are what let our program do the boring, repetitive stuff automatically, so we don't have to write the same code 100 times.
Now, MySQL has 2 main types of loops, and you really got to know the difference. A while loop checks its condition before it does anything. So if that condition is false right from the start, the loop won't even run once. But a repeat loop, it runs the code first, and then it checks the condition at the end. This guarantees it will always run at least one time. That difference is critical.
And you get really fine-grained control inside these loops. So imagine you're looping through a list of users. If you hit an inactive user, you can just use iterate to say it's skip this one and jump right to the next person. Or if you're searching for one specific user and you find them, you can use leave to just break out of the loop completely. It's how you really fine-tune your automation.
So we've built this powerful program, but let's be honest, even the best code can break. In this last section, we're building a safety net. We're going to learn how to plan for errors, handle them without crashing, and figure out how to find those pesky bugs.
Oh man, we've all seen an error like this, right? Your code tries to talk to a table that doesn't exist, and the whole thing just crashes and burns. Now, in a simple query, that's annoying. But in a complex program that's halfway through changing a bunch of data, that could be a total disaster.
The solution here is an error handler. This is basically an emergency plan you write for your program. You're telling MySQL ahead of time, hey look, if this specific error pops up, don't just crash. Instead, I want you to run these special instructions I've already prepared. And this right here, this is probably the most important safety pattern you will ever write. This handler says if any kind of SQL error happens, I want you to exit the program and, this is the crucial part, roll back the transaction. That means it undoes every single change you've made so far. This isn't just a safety net, it's an all-or-nothing guarantee that keeps your data consistent and predictable. It's a lifesaver.
But what if the code runs, but the logic is just wrong? Here's the catch. MySQL doesn't have a modern step-by-step debugger. So we have to get a little old school. The tried and true technique is to sprinkle select statements at key places in your code to act like print statements. By selecting your variables at different points, you can watch how their values change and find the exact spot where your logic went off the rails.
So there you have it. We've gone from a simple query to a full-blown program with data inputs, a brain for making decisions, an engine for loops, and a safety net to catch it when it falls. You now have the tools to build some seriously powerful automation right inside your database. So the only question left is, what are you going to automate first?